First of all, thank you so much for staying and sticking with me here in the session while food is being served outside. Really appreciate that. And I know for a fact that my performance here on stage to captivate you is kind of like makes your decision whether or not to fall asleep in your chairs or just go for food right now, right? And the topic I want to talk about is kind of like related to that. It's not about someone's performance on the stage, it's about the performance of your front-end application and whether or not the customer sticks and waits for the page load and does business on your website or just leaves and does it somewhere else. As you can already have seen in the introduction, my name is Christian. I'm working as a software engineer at Source Labs. I have a lot of responsibilities. One of them is I'm leading the DevTools team, where I'm trying to build up extended capabilities on top of the so-called WebDriver protocol. One of those capabilities is, for instance, extended debugging, where we try to allow you to test network activities of the browser. So if my API calls are being made correctly, things like that. And one that we started recently was performance. And the reason why I got really interested into performance is that performance next to a functional accuracy, the performance of the page becomes more and more crucial. Come on, there we go. According to some statistics, we see that 53% of mobile page visits are getting abandoned if the page takes longer than 3 seconds to load. The average page size last year was 3 megabytes, and this year it will be probably around 4. And the average page loads, every page load on web pages right now, it's already 3.21 seconds. So it's likely that every second person already leaves the page without waiting for the page load to happen. And that's really crucial. Also, Google has their take on that. They say, how fast your website loads is critical, but often a completely ignored element in any online business, and that includes search marketing and search engine optimization. That means it starts with, if you have a slow website, it starts with that your customer is leaving the page without waiting for the page to be loaded, and it ends with Google decreasing your page index and not even show you in the search result. So performance matters. I'm not sure if you have seen this before. The hashtag perf matters is a global kind of movement of developers around the world, of browser vendors and front-end developers, to try people to teach around performance, how you can improve it, to build tools around performance, and to educate, build conferences and meetups. What I was curious about is why is there not really much around testing? I come from the testing space. I was working for Source for a while now. I haven't seen really much around testing. How can I test the performance of the website? And that's what I want to show you today. Let me start off with a quote from someone who's called Harold S. Greenan. He says, performance stands out like a tons diamond, but no performance can be always explained away. Harold was an American businessman living in the 70s. He probably had no idea about the internet, nor about web application, performance development, whatever. But his quote is kind of correct. We all want to have a really performance snappy application that our customers love to use. But we don't really do a lot about improving our performance, and especially don't really test about it. I mean, I cannot really see you all, but I want to see by show of hands who of you has a performance testing step in his continuous integration pipeline. I think I see some hands, which is awesome, but not a lot. So let's see if we can change that today. Before you look into how we can test browser performance, we have to see what browser performance actually means, right? What does it mean if I say, or if I ask myself, how fast does my web app load? And in order to get an understanding about that, we need to look into a couple of metrics. One really important one to start off with is the metric called time to first byte. Time to first byte is the duration that it takes until you put something in your browser, hit enter, and then the browser makes a request to your server, the server computes the request and sends a result. And once the browser has received this first byte of response, we say this is the time to first byte. And it is crucial because it impacts all the other metrics that come after that. because you have to mention if the server is slow, not responding, then the browser is sitting there doing nothing, waiting for the server, and your customer is sitting there doing nothing, waiting on the browser. So if the page load, the time of first byte is slow, everything else will be slow and the user experience will be not great. Then there are some rendering related metrics. The first one that comes into mind is the first paint. The first paint is usually the time whenever the browser has started to render something in the page. This is usually a background, some background gradient, as you can see there. Then once the browser starts parsing more CSS and parses the DOM, it can show the first elements on the screen. And that's what we call first contentful paint. Contentful as of something from the DOM has been rendered on the page. It can be an element, like a paragraph, it can be an input element, what you have. Then there's a while nothing until the whole page starts to build up, right? The whole HTML has been parsed, we see the first images, and once we see the most dominant element on the screen, we call this the first meaningful paint. And last but not least, once the student is ready to interact with the page, we call it time to interactive. And if you are asking now why this guy was stuttering, it is how flakiness feels if your page doesn't load correctly and smooth. Okay. Then we move on to a score-based metric, which is called speed index. Speed index is really interesting because it tries to compute the overall score of how your page has been rendered. There are kind of two types of how you can render your application. You can see it in an example. There's an optimized web app that uses progressive rendering, and there's an application that is not optimized. And for progressive rendered apps, they usually render and display things as soon as they are being parsed and loaded. And you can see on the right, the colored area is the part that has been rendered where something is shown on the screen, the amount that has been shown on the screen. And for a progressive rendered app, you see a lot of things that comes right away, right? And for a non-progressive app, there's a whole time nothing, and then everything pops up in the beginning. And the speed index is pretty much the white area on top of that. You want to have this white area as small as possible so that the overall user experience for the customer is great. So to sum this up, there are three kind of metrics that we can look at. There's a milestone-based metrics that we have seen with time of first paint, first contentful paint. There are score-based metrics. The speed index, I would say, it's a score-based metrics as well as a Lighthouse performance score. And we have resource-based metrics, saying that, hey, I want my app to load not more than 200 kilobytes of JavaScript. And if you now ask yourself, well, this is a lot of metrics to care about, right? Are these all even important to us? And the answer is yes. Every single metric is in some extent important because they describe the overall user experience of your customers during the page load. And some people at Google, they try to quantify this user experience by raising a couple of questions. And we can go through that. The first question is it happening? So is the server responding to user request? And as you might have learned in a second ago, we can answer that by looking at the time to first byte metric. Then we want to ask yourself, is it usable what I see there? Can the user engage with it? And the metric we can use there is the first contentful paint. Then we want to ask ourselves, is it usable what I see there? Can the user enjoy the things that he sees? And we can answer that question with the time to interactive. And last but not least, is it delightful? Does it really feel snappy? And is it really without flakiness? And this can be answered by looking at the long task and the term so-called jankiness, which we look into in a second. And you can compare this ideology with the scenario where you go with your partner into a restaurant, right? And you sit down and you wait a whole hour until the waiter pays attention to you, asks you what you want to eat, and after a minute he brings you everything, including the check, and asks you to leave. That would be a really weird, experience, and you would probably never go to that restaurant again. What really is better is if you come into a restaurant and the waiter immediately asks you if you want to drink a water or some wine, and then he asks you what you want to start eating as an entree, and while you're eating your entree, he serves the main dish, and while you're eating the main dish, he serves the dessert. And this is a much better experience. So as long as the user is busy, consuming things, it's always a better experience than have to wait for a long time. So Steve Souders said, fast forward today, and we see that window on load doesn't reflect the user perception as well as it once did. And that's really true. We cannot only look at, hey, when is my page finished loading? That doesn't really reflect the user, the user experience. If you say, my app is loading in 5 seconds, you're technically not wrong, but you don't really, it really mispresents the reality. So let's understand how we can capture the performance, how we can test it. And in order to do that, we have to understand first how the browser is understanding a page load. And to get behind that, we have to look into browser tracing. I'm not sure if you have done this before. You open your DevTools application, and you go onto the Performance tab, and you click this record button, and you see all these interesting flame charts with the JavaScript function being executed. It looks kind of fancy, right? So I was asking myself, where does this information come from? And the answer to that are trace logs. So if you do this kind of recording of a trace log, the browser pretty much dumps all the information he has to a JavaScript object. And there are many so-called trace events that describe a specific event. Those events have a specific name. They are ordered into a specific category. They are from a specific type. They are duration events, complete events, instant events, and so on. You can read the whole trace event format if you like. But what you need to know is it's connected to a process ID, a thread ID, which is not that important, but more importantly, it has some arguments. It comes with some data, what that event stands for. And usually you would never open your IDE and would look into the whole trace log because it could be multiple megabyte of size. That would be too much to do. So what people do is they build handy applications to make sense of this data. A popular example here is if you do this thing that I showed you a second ago with recording the trace log in your DevTools application, you get this little nice graph that describes the JS heap size, the documents, the nodes, and the listeners that you have registered on your website. And all there is to represent this graph is a bunch of trace logs that are from the updates counters. It's within the DevTools timeline event category. And you see in the data object, it has a bunch of information about all these 4 types. And based on a set of those kind of events, it can display this graph really nicely. Another popular example that you might have seen are these nice little screenshots that you see in your performance tab. Those are called, have a name, screenshot. They're within the category disabled by default DevTools screenshot, and the image is encoded into a base64 image. And it's called disabled by default because capturing that information has a slight performance impact on the browser. So one of these tools, you can use them to inspect your trace logs, but there are even more higher level tools that you can use. One of them is, for instance, Google Lighthouse. If you haven't used it before, Google Lighthouse is an excellent tool developed by the people from the Chrome team to get diagnostics about a variety of aspects of your page, not only performance. It includes SEO, PWA, what have you, and it gives you, first measurements that you can do to improve the performance. Another tool is webpagetest.org. It looks like a page from the 90s, but it has a really great value by providing you all this information about what kind of network request your browser did for that specific page load. It gives you all the metrics that I've shown you before and even more, and gives you a good idea within grade even what the performance of your page looks like. But these tools all have a problem and all don't really solve my problem of testing performance. One problem is that every one of those tools, they have an URL that they take, and then they open the URL and give me this exact page load performance metrics. That's not enough. I want to go on, click on a link. I want to log in first. I want to bring this application into a certain state before I measure the performance. Another problem I have with those tools is that they are kind of difficult to set up. For QA engineers or not really front-end savvy people, it's just difficult to set up a Docker image and things like that in the CI. It needs to be easier. And also a big problem is that they don't capture your performance metrics over time. Your page evolves over time, and that needs to be reflected in your way how you assert the performance of your page. So I thought about, well, working as a software engineer for a testing automation company, why can we apply the idea of performance testing to the automated world? And in order to do that, we need to talk about WebDriver, because WebDriver is essentially the automation standard that we probably all use today to automate our browsers and mobile devices. But I've seen a lot of confusion about what WebDriver means. Many people think that's Selenium, right? And that is to do with Java, and I don't like Java, it's too slow and flaky anyway. So I say that's not true. It's not Selenium, not Java. WebDriver is a W3 protocol. One of my other responsibilities at Sauce is I'm a so-called AC rep. So I go to the W3C meetings and sit with usually white man in a small room and discuss about protocols, and one of them is WebDriver. So what WebDriver is essentially, it's an API description. It's an API service. It defines an API. It has some REST endpoints, as you know with any API. Any REST endpoints describes a certain action that you can do on the browser. It's really high level and focuses on the user perspective. So everything that the user can do, you should be able to do with WebDriver. So there's an endpoint to do a click. There's an endpoint to go back, go forward, get an element, and so on. And the way how this usually is being set up is that you have your test script using Selenium or another framework like WebDriver. And those frameworks, they send HTTP requests to a so-called browser driver. Given that the WebDriver is a W3C standard, every web browser has to be compliant to it. So every browser vendor gives us and maintains a browser driver, which is awesome. And those browser drivers have this WebDriver API implemented so that you can just throw HTTP requests to them, and then the browser driver is responsible for doing all this magic in the browser. And there are other tools like Puppeteer and Cypress that have a kind of different approach on that are really focused on a single browser first, because in some cases you want to have a simple end-to-end test in a single browser before you run it on all browsers, which makes totally sense. And in the mobile space, it's even more difficult because the mobile operation systems decide to change their automation framework from one operation version to the next. But luckily, there's Appium, that helps us to have one interface, which is also based on WebDriver, to run the same automation script on all kind of devices. And as I mentioned before, I'm maintaining the WebDriver project, which is a JavaScript framework for automated end-to-end tests in browser and mobile devices. And I wanted to bring the performance aspect of testing performance to that framework first. And since I don't think it's really important to test performance cross-browser, I started with one browser, which is Chrome, which was the easiest for me to get this achieved. And the way how WebDriver works, it has like a test runner that where you can import reporters and services, which are kind of plugins. And one of the plugins that I've created is the so-called WDAO DevTools service. So the DevTools servers leverage the browser internal interfaces of Chrome to allow me to do the things that I need to run tests. And once you set up a WebDriver test runner with the service, you get a bunch of functions that you can run to test the performance with. And I have a small demo prepared for that, and I need to change the monitor setting first. There we go. Perfect. So I have a little website set up that needs to boot. I use Glitch for my demos because you can just change code online and it deploys it automatically. And I have a demo prepared where I hope my app loads. So this is a WebDriver test suite where I have a config file, and the test runner picks up this config file and runs the test according to that config file. And I have some tests prepared. I have defined some options for my test runner. I have created my base URL, the app that I want to test with. I defined my capabilities, so I only want to run things in Chrome. And as you can see here, as my service plugins, I use Chrome Driver and the DevTools service. Chrome Driver, a service that starts Chrome Driver in order I can automate, so that I can automate Chrome, and the DevTools service so I can run my performance test. Then my performance spec is pretty straightforward and simple. I start with a command called enable performance audits, and I give some properties to it that modify the browser in a way that it emulates a mobile device. In this case, it says I want to emulate a good 3G connection, and I want to throttle the CPU times 4. Because if we test performance, we always look at the lower end of the users. The performance of someone who's using a supercomputer will always be great. But we really, are careful about the users that have a flaky internet connection and a slow mobile device. And what I then do is I just open URL, and then I can ask for the metrics of it. And my resource test is pretty similar to that. Here I don't need to throttle because I want to just check my resources. And I want to make sure that overall my all resources are not higher than 450 kilobytes. My images should be compressed, and my scripts should be magnified. So if I run this right now, let me reload. I call the WO command and give my config to it. And what happens is that 2 browser windows start up. They open my demo page. And if everything works, it should pass because I'm a good React developer. I hope. Let's see. Everything passed. Awesome. Let's for the sake of fun, let's introduce some performance problems to my application. So what I first want to do is I want to remove tree shaking. So I say my Webpack config is development. I want to enable some scripts that I don't need, but I am a huge fan of jQuery, so why not? What else can we do? We look in our application, and there we go. There's a function to mine Bitcoin. Excellent. I know the crypto market is hot right now. So let's see. So it redeploys our application. It's ready now. And I just run the same test again. And this time, my test should fail. So you see the page. What the myBitcoin function is doing is pretty much it defers the main thread, so nothing can happen until 3.5 seconds are over. It's like a while loop that breaks after 3.5 seconds. And there we go. So we see our resources test has passed, and our overall performance has passed. So let's see, I haven't changed the image size, so everything is fine there, but you see my scripts are not minified anymore or are higher as expected, and the overall asset size is also changed. And then all my performance tests have changed as well. So this is a really first test that you can run on your own CI/CD with a WebDriver framework and with the DevTools service, and it should be really simple to set up. There's still one problem with this, local approach, or this approach is that you run it on your local machine. And the difficulty with performance testing is that you need to somehow create the same environment to test the performance for. You cannot run the performance test on a supercomputer and expect the same results on a low CPU computer. That doesn't work. So I wanted to bring these capabilities to our cloud, because I know in our cloud the capabilities and the environment are usually always the same. And I mean, I've been working for Source Labs. If you don't know what Source Labs is, you probably remember this screen that I showed a second ago, where you have to, in order to run this setup, you have to set up all the browser drivers, you have to have all the browser installed, and it's even more difficult with real devices or emulator simulators. So the value proposition of Source Labs is kind of simple, right? We just maintain everything for you. You have one endpoint that you can use to access all the devices on-prem, and automate all the browsers with the newest version without any hassle. And on top of that, we provide some logs and give you insights about what happened during the test. And one of those insights is performance. So the reason why we started really care about that is we want to shift testing to the left. This phrase is somewhat a DevOps term, and it means that we want you to do your unit, functional, and performance testing as soon as possible. If possible, even on a commit level, right? We want to avoid bugs that come at the end of the pipeline or even show up in production that really cost us the money. And I looked into the current performance space or the tooling space that we have, and we have Lighthouse and Chrome DevTools, which are excellent tools in order to see the diagnostics of your of the performance of your page. And we have great tools for production, like SpeedCurve or New Relic, that give you real user metrics and that give you an idea of how your users actually use or what kind of capabilities your major users have. But there was really nothing that really made it easy to just plug it in a CI/CD environment and test your performance. And to make it really simple, we created a small sidekick that we called Speedo. Speedo is an open source project. I actually wanted to wear Speedos for my presentation, but the conference organizer weren't happy with that. So I just like myself now. So Speedo is an open source project. It's written in JavaScript. If you really want to get started on performance testing, you can use that because it doesn't require any knowledge about Selenium WebDriver or any knowledge about how to set things up. As an example, you can see the way how to get started is you install Speedo using npm. You can use also a Docker image if you're more familiar with that. And you say Speedo run, and then you give an URL. And there's a bunch of capabilities or parameters you can add to that. But that's pretty much all you need in order to run a performance test in the cloud. And in addition to just running it, we also help you to assert the performance over time. So I have a demo for that as well. So my page is still up. So as you remember, I added some performance problems to my page. And I was running Speedo tests before. And what the Speedo test was doing before is it would gather all the knowledge about how the usual page load of my application looks like. And it's now able to automatically detect whether or not something goes wrong. So I've prepared a demo call. So here's my Speedo call. So as I mentioned, you call Speedo run. You give it an URL. You can pass in some parameters. In this case, I pass in a test name, TestCon demo. I add it to a build. And I want that this performance test is running in an emulated environment of an iPhone 10. That means that it automatically changed the user agent for you, so it shows up as a mobile device. And this has the right dimension as mobile device on an iPhone 10. And it also throttles the network. So what happens now is that it starts its job in our cloud, running on a Chrome browser, but in an emulated environment. And then it downloads all the assets after the performance test has been run. And at the end, it asserts the performance. And right now, I'm just looking at the Lighthouse performance score. And you see I failed greatly in that. But you can also see you can test against various of other metrics that I've shown you before. And what's great about that, it doesn't even only checks the performance and asserts against it. It also gives you a Lighthouse report that you can use and see immediately, hey, why was the performance of my page that bad? So you get a bunch of information for free to just start digging into, hey, why the performance was so bad in this case. And you know, speed of run is the one opportunity. You give it a page load, but then it would be kind of like, hey, that seems like Lighthouse in the cloud, and you're not really that wrong about that. We do additional things that are really important, and I mentioned before. We capture the performance of every page load, not only the one that you intentionally open when you intentionally open the browser or a specific website. We get you the performance metrics of every page transition that happens. You have an example here where I want a performance test and I log in into Instagram. And my goal here was to check the performance for the actual feed after I logged in, which is really the important part if it comes to user experience, right? Because no one is interested how fast your login works. Everyone is interested in how fast your feed works up. And of course, you can tweak around and insert cookies before you open the feed page and probably get around that, but this is a really great way to actually test the user flow from A to B, or from the begin to the end. And with the analyze command that we also provide, you can specify specific metrics of your automated test that you have been running before and assert the user metrics or the performance metrics of that. And as I mentioned before, Speedo is ready to be used in CI/CD. So as we mentioned, we provide a Docker image, so you can just set the Speedo base image in your configuration, and you can use Speedo run whenever you have done your unit, your functional, and your functional test. But as you see, you not only need to use Speedo, you can also build your own performance framework using Selenium or WebDriver. And the way how we provide that is with WebDriver extensions. So the protocol allows vendors to extend on the protocol to allow new kind of capabilities on top of it. And we provide these extensions that you can either call using frameworks that already have adaptation for that new extensions, like WebDriver, or you can just use any Selenium binding to use the JavaScript executor workaround. So with the assert performance command, for instance, you can assert the performance directly in your test, and you can, bring the application to a certain state before you do the testing. Another really great thing is that we not only care about the hard page transitions, which mean that you open a page from the beginning, we also look into soft page transitions. So here's a great example about Postmates.com, which is a full single page application. That means there's one, you load the page once, and everything this is there moving on. So once I enter something into the search box, I want to have food in San Francisco, it doesn't load a new page. It just calls the API and changes the views. And we have modified Lighthouse in a way that it can generate these performance reports for those kind of soft page transitions. Before we end up the talk, I want to go into jankiness and what that means. And as you probably heard in the beginning, we move more and more stuff to the browser. We run more and more JavaScript. The browser these days, it's a JavaScript power plant, right? And that doesn't change much, and we are responsible for that. Because we move more and more scripts to the browser, all the application logic is in the browser, and with that also the script size, and more importantly the third-party scripts, the ads and the analytics scripts, they all increase the payload and the computation effort of the browser and makes the page somehow flaky. And over 50% of what happens in the browser is JavaScript computation. So we cannot get around it. And if you have a lot of JavaScript in your page, the browser has to do a lot of things and can start feeling flaky and unresponsive. So we are looking into that, and if you don't know what jankiness means, there's some sort of stuttering and juddering or just plain halting that users see when a site or app isn't keeping up with the refresh rate. It is the result of frames taking too long and browsers for the browser to make, and it negatively impacts your user and how they experience your site. So it's like really the scrolling can feel not really smooth, or when you input something, it takes a long until you see the change in the screen. And we are thinking about how we can measure that kind of jankiness, and we use some sort of similar approach to that. we created another custom command that we called jankiness check. And what it do in the browser is it would scroll from the top to the bottom of the page, and it would then also captures all these trace information that the browser provides. And it would then try to make sense or try to find out how much the browser actually was busy doing stuff and how high was the frame rate. Based on that information, we create several scores for how well you did with the forced layouts, how well you did with the average FPS rate, how well you did with the memory size, and that computed together, we create an overall score that you can use to test the flakiness. So if we see that the browser is really doing a lot of things and the FPS rate is low, then we give you a warning, or you can assert against it unless your test failed. That was quite a lot. So we started with looking into performance metrics, what that means, and we started looking into how we can even capture these performance metrics. And we just ended up at how we can test not only a soft and a hard page transition, but also the jankiness of a page. Before I end up, I really want to quickly go over some best practices that we have discovered so far. One is, and the first one is really important, don't combine your functional and your performance test with each other. You should always run your functional test first and then performance at the end. If you remember the testing pyramid, where you have a lot of unit tests, a bunch of integration tests, small end-to-end tests, and then the performance tests are like the sprinkle on top of it. You should not worry about different browser versions or operation systems, because usually the browsers do a lot of benchmark tests and make sure that the performance of the browser is the same. You should keep it simple. That means that you should not test all your pages for performance, just the ones that are really important for your customers. You should maintain, if you run tests on source apps, you should maintain one job name for all your performance tests, because based on the name, we can identify the history of your performance. And at the end, it is good to start with a simple performance score, the Lighthouse performance score. But if you have, for instance, an e-commerce website, you also want to look specific metrics like time to first paint in order to find out, hey, is the search bar visible for the customers as soon as possible? And with that, I thank you all for listening, and I'm open for any questions.